At first, the data looked wrong. Not interesting wrong. Not unexpected but plausible wrong. Just wrong. The kind of wrong that usually means a calibration error, a bad pixel, a timing glitch, something mundane that would be fixed by rerunning the pipeline and moving on. When the early detections of 3IATLAS began circulating quietly through internal channels, that was the assumption. Someone mistagged an object. Someone mismeasured its velocity. Someone forgot to subtract background noise. It happens all the time. Astronomy is full of ghosts created by software. So scientists did what they always do when something refuses to fit. They tried to dismiss it. 3IATLAS wasn't supposed to exist in the first place. Not like this. Objects that pass through the solar system follow rules, well-worn ones. Even interstellar visitors like Oumuamua or 2I/Borisov, strange as they were, still slotted roughly into expectations once the shock wore off. Their paths could be reconstructed. Their speeds made sense. Their behavior, while unusual, didn't repeatedly poke holes in basic assumptions. 3IATLAS did. The first issue was its motion. It wasn't just fast. Plenty of things move fast. It was fast in a way that didn't line up cleanly with known gravitational interactions. The velocity vector didn't behave the way models predicted when traced backward. When astronomers ran simulations to see where it came from, the solutions sprawled uncomfortably, like equations that refused to converge. You could force a fit, but only by stretching assumptions to the edge of credibility. That alone would have earned a footnote, maybe a short paper. What made people uneasy was what happened next. As more observations came in, 3IATLAS didn't settle down. Its light curve, how its brightness changed over time, refused to smooth out. Normally, as you collect more data, the noise averages away and a clear pattern emerges. Here, the pattern kept changing. Small fluctuations appeared where none were expected. Then they disappeared. Then they reappeared slightly out of phase. At first, the explanation was easy. Irregular shape, tumbling rotation, uneven surface reflectivity, all very normal, especially for an object that may have spent millions of years drifting between stars. But when teams modeled those factors, the numbers still didn't quite match. You could explain one oddity, you could explain two. Explaining all of them at once started to feel like stacking excuses. Still, dismissal came naturally. Extraordinary claims require extraordinary evidence, and no one wanted to be the person who overreacted to a statistical hiccup. So the language stayed cautious. Words like artifact, bias, and selection effect appeared again and again in draft analyses. Emails circulated suggesting additional filtering, alternative reduction techniques, reprocessing with stricter thresholds. If you squeeze data hard enough, you can often make it behave. Except 3IATLAS didn't. Every time a new dataset was folded in, the same problems resurfaced. Independent instruments, different teams, separate software pipelines, all converged on results that were uncomfortably consistent. The anomalies weren't going away, they were repeating. That's when the second attempt at dismissal began. Reframing. Instead of asking, why is this object behaving strangely? Researchers asked, what category can we force this into? Maybe it was a fragment of a disrupted body. Maybe it was an unusually porous comet with outgassing patterns that mimicked non-gravitational acceleration. Maybe it was a binary system masquerading as a single source. Each idea bought a little breathing room. Each one also came with its own problems. For instance, outgassing should leave signatures, specific emissions, changes in spectrum, telltale jets. Observations hinted at activity, but not enough to fully account for the measured deviations. A binary explanation struggled to reconcile the timing of brightness variations. Fragmentation didn't line up with the object's apparent structural stability over time. None of these explanations were impossible. They were just unsatisfying. What really unsettled people wasn't any single inconsistency. It was the persistence. 3IATLAS kept doing it again, whatever it was. Whenever scientists thought they had it pinned down, adjust a model to fit one observational window, and the next window slipped through. Explain the motion, and the brightness misbehaved. Explain the brightness, and the trajectory raised its hand again. Quietly, the tone shifted. Internal discussions became more careful. less dismissive. Not because anyone wanted to sensationalize the object, but because ignoring it was starting to feel intellectually dishonest. The data were what they were. You could downplay them in public language, but in private, people were paying attention. One astronomer described it as a low-grade irritation. Another called it that thing you don't like thinking about too much because it eats time. Time is precious in science. Chasing anomalies can wreck careers if they go nowhere. Most turn out to be boring in the end. The danger is mistaking boring for safe. As 3IATLAS continued its passage, additional measurements refined its size and shape constraints. It appeared elongated, perhaps dramatically so. That alone wasn't unprecedented, but combined with its rotational behavior, it suggested internal properties that were difficult to square with standard formation scenarios. If it formed in another stellar system, fine. But what kind of environment produces something like this, and how often? Frequency matters. 1 odd object can be waved away. 2 raises eyebrows. 3 starts to feel like a population. That's when comparisons began, cautiously at first. Not public ones, not the kind that make headlines, but quiet acknowledgments that 3IATLAS shared uncomfortable similarities with earlier interstellar visitors, while also refusing to be just a repeat performance. It wasn't a carbon copy. It was improved, sharper, more annoying. Some researchers joked darkly that the universe was messing with us. Others pushed back hard against any whiff of narrative thinking. Nature doesn't send messages. Objects don't refuse explanations. They just are. The discomfort, they argued, came from our incomplete models, not from anything inherently strange about 3IATLAS. That's probably true, almost certainly true. But here's the problem. Science progresses by expanding models when reality keeps bumping into their edges. And 3IATLAS was doing a lot of bumping. Attempts to fully dismiss it began to sound strained, even to the people making them. You could feel it in the phrasing of conference talks. Longer pauses, more qualifiers, slides that lingered on error bars a bit too long. The careful dance of acknowledging anomalies without giving them too much oxygen. Then, once again, 3IATLAS did it again. A new analysis, using a different observational window and a revised dynamical model, confirmed a subtle acceleration component that shouldn't have been there, at least not at the measured magnitude. It wasn't dramatic, it wasn't sci-fi. It was just enough to be annoying, enough to survive statistical scrutiny, enough that you couldn't pretend it vanished into noise. No single result flipped the table. That's not how science works. What changed was the cumulative weight, the sense that every attempt to make the object boring failed by a small but persistent margin. Death by 1,000 paper cuts. Publicly, the language remains restrained. No one serious is claiming impossible physics. No one is whispering about intelligence in peer-reviewed journals. But behind the restraint is something more interesting: attention. Sustained, cautious, unwilling attention. 3IATLAS is now a benchmark, whether anyone likes it or not, a data point that future interstellar objects will be compared against. A reminder that the solar system is not a closed box, and that visitors from elsewhere may not arrive pre-labeled for our convenience. The real story isn't that scientists were wrong to dismiss it at first. Skepticism is the system working as intended. The story is that dismissal stopped working. Reality kept intruding. The object kept misbehaving just enough to demand better questions. Maybe in the end, 3IATLAS will be fully explained by physics we already understand, just applied in combinations we haven't explored deeply enough. That would be a win, not a disappointment. It would mean the universe is consistent, even if it's occasionally rude. But even if that happens, 3IATLAS will still matter, because it exposed how thin the line can be between known unknowns and things we thought we understood. It reminded researchers that the universe doesn't owe us simplicity, and that interstellar space may be delivering samples we're not quite ready to categorize. Scientists tried to dismiss it, because that's what you do when something doesn't fit. You test it. You stress it. You try to break it. 3IATLAS didn't break. Instead, it kept showing up in the data, quietly, stubbornly. Doing it again.